Okay, so number 2, let's go ahead and look at the parent function. F of x equals x squared. And I'm going to make my table f of x, which is the y values, 0, 0. And then let's see, it's a 1, 1, negative 1, 1, and 2, 4, negative 2, 4. Okay, you can tell that either there was a horizontal stretch, it stretched this way, or I should do the other function. It stretched that way, horizontal stretch, or we could also call it a vertical compression to produce that green function. Okay, so let's go ahead. I know that there's going to be a multiplier. That's what I'm trying to say. Okay, it's not just going to be straight like multiplying by negative 1 to get to where you need to. You need to multiply by a number, either the x or the y. So what I'm going to do is I'm going to match up what g of x. So g of x. And I'm going to put it out here because I know it's going to involve intermediate steps. So x and then g of x. So let's go ahead and put our vertex 3 and 2. And the only clear points, I've already circled it, 5 and 4, and 1 and 4. Okay, so those are the points that I'm working with. Okay, since x is the more complicated, I always like to put the multiplier on my y. You can do it on both, but I always like to put it on the y because it just, I don't know, because with y what you see is what you do. Okay, and so I look at my vertex and I look at my x and I get my x done. Okay, the way that I get my x completed is I just look at from 0 to 3, how did it move? So add 3. Okay, so if once I add 3 to it, my new y, it's not going to be called f of x anymore. It's going to be a new function. Is going to be 3, 4, 2, 5, and 1. Okay. Now notice on the green table that the vertex matches up, the x value of the vertex. The 4 and 2 is no longer found. Okay, and then 5 and 1 match up. Okay, so 5 and 1 match up, and from the green function, you notice that with the parent function, if 5 and 1 match up together, then the y value did not move at all. Okay, it didn't move at all. Okay, but then what I'm going to focus on is the 4 and 2. Okay, what I'm going to focus on is the 4. Look where 4, right here, let's put it in purple. Look where 4 and look where 2 is. Okay. It looks like 1/2. It's like in between 2 and 3. 2.5. Okay, 2.5. So I can do it that way. Remember the counting for the first point, but I'm not. I want to give you a way for you to be able to do it for every really difficult transformations. So since it just adds up, you're like, nothing happened to the y, so couldn't I just fill it out? Well, if I do that and I just replicate this, get rid of those arrows. Of course, not going to get rid of that one. And then 4 and 4. Yes, 5 and 4 now match up with 5 and 4, and 1 and 4 matches up, but the rest, the vertex doesn't. You notice the vertex? They're different. So something happened to the y. We just don't know what it is. If we didn't do it to the x, we have to do it to the y. We need to multiply it by some kind of number, and we need to add it by some kind of number. Okay, the 0 is really good indication of what number it gets added. So it gets added by 2. So we know that all of these, we're going to add 2 to it. Now, if I add 2, that works. But if I just add 2 to all of this, remember 5 and 1 are supposed to match up. Okay, so if I add 2 to all of this, it becomes a 3 and a 3. Okay, and a 6 and a 6. It doesn't match up. So something had to multiply it first, and then it had to add 3. You had to add 3 to it. So what can I do to 4? The original 4 right here. Multiply it by some kind of number and add 2 to it for it to become 4. Okay, so I just wrote myself an equation. Hey, I just wrote myself an equation. Minus 2 minus 2. So 4x equals 2. X equals 1/2. Could I multiply these by 1/2? Okay, could I multiply the original function by 1/2 and add 2 to it? Let's check to see what happens. Oh, this is time. This is exciting. Okay, multiply it by 1/2 and add 2 to it. Multiply 0 by 1/2 and add 2 to it. Matches up. Multiply 1 by 1/2. That becomes 1/2. Multiply it by 1/2. It becomes 1/2. It becomes 2.5. Okay, multiply 1 by 1/2. It becomes 2.5. And the numbers that I need to check, these two that linked with all of that, 1/2, half of 4 is 2. Add 2 to it, 4, and 4. Okay, those look like really big negatives, but this and these points. Okay, and then these points. And then you figured out your thing. You figured it out. And if you take a look, remember I said the first point, and sometimes the first point is not an integer. It just becomes slope. Okay, and so you went right 1 and up 1/2. Okay, so that's 1 over 1/2, which ends up becoming 2. Okay, which is the reciprocal of 1/2. And you can just drop that right into the function. Okay, but we're not going to go there. That's too complicated. Okay, so now let's take a look. So for x, we added 3. And for, I don't know why there's a hole in there. For y, we multiplied it by 1/2. And then we added 2. Okay, now if I describe this, that's a horizontal shift. If I write 3, and that is going to be a vertical. It's multiplied by 1/2. So a vertical compression by scale factor of 1/2, and it's going to move up 2. Okay, and then we need to write a function for it. So g of x, okay, what are the things that are being done to y? And with y, what you see is what you do. So you just drop it in. 1/2. Okay. By the way, if you do the counting method, it's going to give you the x multiplier. That's why you get a no, not really. Yeah, it does, because it's affecting the up. So the up would be a vertical. No, it's 1/2. Yeah, 1/2. What am I thinking? It's the reciprocal of 2, but still. Right? Up 1/2. Oh, it's up. Oh, duh. Slope is rise over run. Okay, so it would be 1/2 anyways. Okay, so 1/2, and then remember up 2. So whatever the rest of the function is, we're just going to put plus 2 out there. Now let's open up the function. We put a square there because it's a squaring function. And then we're going to represent the right 3 by taking the opposite. Or if you want to write it the universal way, that would be g of x is made up of first multiplying the y by half and taking the function, adding 3 to the x's, and then adding 2 to the y's. And there you go. I hope I explained that. You're going to get more of those problems, don't worry. Okay, bye.